Good afternoon, Devoxx. How was the tortillas and the kebab? Was it good? I thought about getting some myself, but I would probably spill it all over my shirt, so and I would look like an idiot on stage, so I didn't get any. Welcome, thank you for joining my talk. It's called Innovation Without Asking Permission. It is about the use of new technology, new tools in existing legacy systems. So just a small question to all of you. Who here really likes new technology, new tools, new methodologies? So who likes using those? All of you, great. And who likes to ask permission before he does something, he or she does something? 3 of you, all right, great. So you guys should probably leave because this is not what the talk is about. So my name is Bart Blommaerts. I'm a hands-on application architect. I live and work in Belgium. And in the beginning of this year, I actually started my own company. It's called BB Consulting. I was not very original with that name. And I'm currently working with a financial customer. If you have any questions for me or remarks or just random thoughts, you can always find me on via Twitter. Let's get started. Software development is awesome, just like the Koenigsegg race car. If you are a software developer, you know that everything changes in our industry. A couple of years ago, we were still doing server-side rendering, then we went to client-side rendering. Now we're going back to server-side rendering, but on the client, micro front-end kind of things. So there's a lot of things moving on. And if you're passionate about software, then you visit conferences like this one, then you follow the influencers on Twitter, then you go to Reddit or to other sites just to stay informed, to stay on top of your game. And it's really exciting. All conferences introduce new technologies like blockchain or deep learning. All of these topics are presented at this conference, so you can learn all about those. And it's really exciting because it never gets boring. It's a great industry to be part of. And then after the conference, we go home. I wonder, how many of you people are currently working on a project that started over a year ago? So almost everybody. 2 years ago? Still almost everybody. 3 years ago? 5? 10? There is a remarkable amount of people who are working on older systems. But that's okay. That's actually a good thing, because it means that those systems are being used. When you create a new greenfield application, you don't know if it has any value. There might be no users whatsoever. It might just be something to throw away. So legacy systems, existing systems, well, they're cool, they're neat, they have proven their value. But still, we want to learn new technologies. We want to do serverless. Everybody needs to do serverless right now. I mean, are you still doing microservices? That's so last year. Nobody's doing microservices anymore. And then you can do pet projects or things on the side, and you should do that because it's really fun. I should encourage you to do that. But wouldn't it be really nice if you could look at your legacy application and say, okay, maybe I want to do some new things with that application. And that's actually what this talk is about. And I would like to start with a quote that I saw on Twitter about the colossal gap between the things that people talk about at conferences and the problems that we're actually trying to solve. Conferences like this one, they want to inspire the developers. They want to be aspirational, and that's a good thing. But I don't think that there always should be a gap. I think that technology and methodologies right now exist to bridge that gap. So one of the first things when you're working with an existing application that you want to look at to use new technology is to investigate service decomposition. Now, this is not a talk about microservices, because microservices were so last year. This is also not about the benefits of microservices. There's plenty of talks about that. Today, I would like to talk about using microservices as a means, as a goal to a certain end. So it's not only about the fun stuff, it's actually about the hard stuff. So what service decomposition means, it's about splitting up an existing monolithic large application into smaller parts, and then maybe some of these smaller parts can use new or other technology. And they will allow for easier testing, deployments, etc., etc. So there are 3 approaches that exist regarding service decomposition. There is the split pattern, which is about moving parts of an existing application to a new application or to a new service or a new microservice. There is the strangle pattern where you re-implement certain parts of the application, and then there's the extend where you just prevent the existing application from growing. Let's look at these into detail. So often existing applications are organized using horizontal technology layers. So the classical n-tiered application where you have a view layer, a persistence layer, a controller layer, etc. These kind of applications are not suited best for splitting up because it makes no sense to have like a persistence microservice. That just doesn't make any sense because every call from every other microservice would need to call the persistent microservice. So in a distributed application, one tier can just not run by itself. On the other hand, when you have an application that is structured around vertical functional boundaries, then splitting up makes a lot of sense because that particular package, for example, in your application, already contains all of the information it needs to run by itself. So when you find yourself in that kind of situation, splitting up will probably be easier. Unfortunately, that's not a very common approach. Well, it was not a very common approach in the past. Now, this does not mean that you need to do everything at once. If you have a very large monolith application, you don't need to start looking at everything that can be splitted off. You can start with one small step and then learn from it, refine what you're doing, and making sure that you can create new services. Strangler, the Strangler pattern was actually made famous by Martin Fowler in 2004. That's 14 years ago, but it's still very valid. It is about identifying a domain of change. Things that need to change in the application anyway. And then you can extract that information from your legacy application and re-implement it. So the goal of this is just to make the existing monolith, to make it smaller. And to enable to do this, to be able to use the new domain models, there's something that's called an anti-corruption layer, and I'll touch upon it briefly in just a second. And then lastly, there is the extend approach, where we try to minimize changes to the existing application, but implement these new features as microservices, as services. Now, what's important with this pattern is that we need to minimize the coupling between the existing application and the new application, because if there's a lot of coupling, then it doesn't really make a lot of sense to create the new microservice. If you have seen Sander Max talk today about modules versus microservices, that's exactly what this is about. We don't want to create a distributed monolithic application because we will introduce all the complexity without the benefits. So when done successfully, this can prevent the monolith from growing. But you do not need to stick to a single approach. So in the demo that I will be showing later, I'm going to show the strangling part of the application, because I think that's the more difficult approach. So we'll see that in a bit. In reality, when you're creating a microservices system, you will likely use a different of these patterns in the same application. So the anti-corruption layer has the goal of the anti-corruption layer is to make sure that different models can be talking to each other. So imagine that you have an existing application and it has his domain model, and you're changing to a new services-oriented application. It might probably need a different model. So they need to communicate with each other. So the benefit of using an anti-corruption layer is that it is possible that all the different services use a model that's optimal for their specific use case. So if your application needs to deal with a database or with another application model, and the domain is not something that's desirable or that it's applicable to what you're doing right now, you will need the translation model to decouple those domain models. It's also an effort to minimize coupling across bounded context, but we'll talk about bounded context in a bit. So this anti-corruption layer is sometimes also called a mapping layer, which is just mapping values from one side to another side. An anti-corruption layer deals with data, not this data, but it's similar. There are three approaches to deal with data. There's the shared repository, there's the data synchronized repository, and finally the event-driven synchronized repository. So when you look at a typical application that's like 10 years old, you will see that it has generally one large database, and the database is being used for everything. It doesn't really matter how the application is layered because it's going to query the database fairly often and in a simple way. So this is a very common approach. Everybody who has worked with software in the past couple of years has seen these kinds of applications. But well, we want to be innovative. We want to use new technology for new use cases. So we think, okay, we want to introduce microservices. And these microservices, they come with their own custom tailored domain. However, these microservices, they might need data from the existing application. So how are we going to exchange this data? Well, we introduce an anti-corruption layer. So it will take care of the domain translation between the legacy database and your new system. Ideally, it also has some kind of API. Then the microservices can call the API as its persistent layer. So that's like a first step in decoupling services from each other. But the problem is that, well, we need to do more. Imagine that we change something in the data model, then potentially we need to change it in multiple places. We need to change it in the existing monolithic application, in the anti-corruption layer, and in the microservices. So that's not something that we want. We want to do something better. And the first thing that we can do for that is introduce new databases. It's all about the polyglot persistence. So each microservice gets its own database, and the database gets fed from the master database in the monolith. Ideally, the database will update the other databases asynchronously, and it can be a bidirectional connection. So when the monolith application needs something from the microservices, it can also receive them. But finally, what we're really after is called event-driven synchronized repository. This is also what I will be demoing later. I think this is one of the final steps regarding microservice maturity. Because it is focused really on loose coupling. So we introduce some kind of queuing mechanism, and we have the anti-corruption layer as a subscriber on the queue from the monolith. So the monolith publishes events to that queue. They will be observed by the anti-corruption layer, which in turn will republish those events to more specific queuing queues for the microservices. When doing this, chances are that we will need to do some refactoring in the monolithic application as well. But I don't think that should be a large problem. Now, I've been talking about events, about event-driven synchronization. What are these kind of events? And generally, an event is something that has happened in the past. It is, in my opinion, probably the best way to ensure full encapsulation and loose coupling. And an event, and that's very important, can contain three kinds of data. There's the data that it owns. So when a publisher publishes certain events to a queue, the data that publisher owns, that should be in the event. When consumers of these events need data that's in the master, then they should not be calling the master anymore, because then again, we're building a distributed monolith. The second kind of data that we put in the event is that data that it needs, so maybe data where the publisher is not master, but it has access to the data, and it wants to put it in the event. And then finally, reference data. So the example I always give is if you want to book a holiday, maybe you want to have the last 5 years every month to know what the temperature was of wherever you're going. So this kind of reference data. Now, very important, events focus on business capability. So an event is not a representation of a table in a database or of a record in the database. Bounded contexts. Typically, bounded contexts depict the boundaries of the microservices. I think most people will probably have heard about bounded contexts and maybe have used them in the past. It was made famous from domain-driven design. Now, I think domain-driven design is very interesting. There was a very interesting talk about it this morning here as well. But it should come with some warnings. There's a link, a video from Greg Young. I will share it at the end, about something called DDD Lite, and it's about the common pitfalls and reasons why a lot of DDD projects fail. So anybody who is interested in doing a project using DDD, I think you must see the video at least once, and probably a couple of times. Now, there's a lot of theoretical talk about bounded context, but you really rarely see real-life use cases. So, allow me to do that. A couple of years ago, I worked for the postal services in Belgium. I won't go into the details, but some brief introduction about what we're doing. So in Belgium, by law, the delivery people, they are responsible to pass every house at least once. So it's legally obliged. And the delivery people, they deliver goods. So in the past, it was a lot of letters, then it was packages. Nowadays, even in Belgium, you can have the delivery people set up your decoder for video. In Denmark, you can hire them to do chores in the house because they need to pass there anyway. So there's a lot of change going on in that area. And also, if you look at distributing letters, it's different from distributing packages because some letters are delivered by bike, others maybe by car or by motorbike. Maybe Amazon will be doing drones soon. So actually are already doing drones. So things are changing. And some of these have time constraints. So for example, large companies can say, I want my mail at the door before 7 o'clock, and I'm willing to pay for that. Or they can say, I want all my mail packaged, and I just want one package a week because I have no time to be looking at all the commercial information that I get anyway. And then finally, and I don't know if this is a Belgian problem, but in Belgium, new houses get built, new streets get built, or they get new names. There was something in the news a couple of days ago that they're actually changing a lot of street names in 2 municipalities in Belgium because there were duplicates. So that's very typical. And what's funny about that is that the postal services don't necessarily know about these changes. So reality is changing, but the postal services, they don't know about it because Belgium, I guess. I don't know if that's the same in Poland, but it is a fact. So you can imagine if you want to do an optimal route calculation, that it's very difficult. It changes a lot. So we want to make sure that the delivery person gets to the places where he or she needs to be as effective as possible. It's a very time-consuming process. It changes all the time. So maybe it can benefit from software or from programming languages that really are suited for calculation. Maybe it needs some kind of scalability, and that's our domain that we'll be looking at right now. So we need to figure out where this new microservice for the calculation, where it will start and where it will end. And we are going to retrieve this information from our legacy monolith. So this means that we need to focus on business capability and not on the technology layer. So we need a deep understanding of our monolithic application and with the business about it. So we need to really be obsessed about the business to make technical innovation relevant. So identifying this bounded context, we talked about mail delivery. A couple of subdomains can be the optimal route calculation. That's our focus for today, but there will be others, and there can be multiple domains in a certain application. Now, one rule of thumb is don't start too small with the subdomains. You can always extract new subdomains from existing subdomains, and these subdomains map with bounded contexts. Now, it's easy to give these examples because I've seen the application. A lot of time people want to know, okay, how do we do this? And there's 3 ways of doing this. It is about talking to your business stakeholders. In general, they should know what they're talking about. It's not always the case. So what generally works well for me is making a formal list of all the potential subdomains and explaining what they do and why are they doing this. If you go over that list with your stakeholders, or even better, have them work together with you on the list, you can identify all the different bounded contexts, and you have some kind of documentation already available. So when you're creating your new microservice, use that documentation in your API documentation. You can do it from code using Swagger or HAL or whatever format that you like. You already have a base for your documentation. Now, to validate this formal list, you can even go one step further, and you can assign use cases to the bounded context. Now, this will be time-consuming, so I advise to do that maybe only a couple of times, or at the beginning of the project when you're getting to know each other, when you're trying to define this ubiquitous language between your engineers and your stakeholders. And then in later phases, it's probably more useful to talk about the use cases and which bounded context they belong to when you're doing, for example, a sprint planning, because you know that's the exact moment where you want to start implementing something. So as an example, in our use case, the delivery of packages in a rural city can be a use case in that bounded context. It happens that your business stakeholders don't really know where they are in the lifetime of the project. It is even more common that they really don't know where they want to go. but you want to go on. So second thing that you can do is look at the data. Most systems have some kind of database. So if you're lucky, your database will be very nicely documented. It will be up to date. Chances are slim that that's ever the case. So you'll need to be reverse engineering your database and trying to see what is being stored in the database. So looking at the data closely is probably one of the best ways to decompose a monolithic application when your business stakeholders are not playing along nicely. And then the last one is looking at the codes. So when you have no domain experts, when the database is a total mess, then you should be looking at the code. But not just the code. It's actually also about the history of the code. So generally we'll all have some kind of version control system, like Git or something. You can query Git, or you can write scripts yourself, see at which files always get committed together. Likely they belong together. Likely they will be part of the same bounded context. There are some tools from that do that as well, but it's probably easy just to script it from revision history. When we have identified these bounded contexts, well, we will need to integrate them. Interesting applications don't live in isolation. So there are a lot of integration possibilities. There's one book that I really recommend everybody reading. It's about the Enterprise Integration Patterns book by Gregor Hope. In general, I personally think that these kind of integration patterns are like super interesting. It's the core thing to be looking at, especially when we're building distributed systems. It might not be the most popular topic, but I really urge everybody to investigate it. So what will our demo look like? So we have the monolithic application on the left-hand side for you guys, and we're going to be publishing messages to a certain queue, events, and then we have a new microservices that will do the round calculation. So the rounds are passing by the houses, and it will do the calculation based on the information that is available within the queue. So this new microservice, since it's being extracted from the existing application, we can do it with new technology. We don't need to stick by a certain version of struts or maybe hibernate older version. We can do new cool technologies. Now, in this picture, you can only see one domain model, because we're really focusing on the delivery. There will be multiple domain models. And for example, managing the users or managing the payments, they can be different domains. When we're trying to identify these domains, it's again useful to look at the data model. A well-designed application may have a schema or a database per domain. If you have a poorly documented or written application, that will not be the case. But what you can do is draw some kind of context map where you say, okay, how do these domains influence each other? Because when we're really focused on one microservice, we might lose the bigger picture, and that's something that we want to prevent. Demo time. If my computer wants to play along. So that's the next slide, don't read it. So, what's this? So there will be, no, we have half an hour for the demo. I'm going to start RabbitMQ. It can be any queuing technology that you like. It's just really simple to put Rabbit on. So, starting. So I will show two applications. So there's the legacy application, if it wants to start. And then there will be the new application, but it's a bit slow. So I'm going to start the new application. I'll do some explanations about it later, but we'll need it running if it wants to. So I'm starting that one. So generally when we're looking at an existing application, it will look something like this. I'll magnify that a bit. Okay. So this is your general calculation algorithm. Is that readable? So any decent calculation algorithm starts with initialization of a bunch of things. So that's here. The calculation itself, the algorithm is not important for the demo, but the first thing that we see, and a lot of applications do this, is we're getting calculation info. So when I was talking about having events contain all the data that's needed to process them, this is the exact opposite from that. It is really easy to just get the calculation info. It's only one query away. In a distributed system, that's not the case. So then we will be doing some kind of calculation. We're going to persist stuff, we're going to update stuff, and we get more calculation info because, well, whatever we passed to the calculate method doesn't have anything useful for us. So very briefly, the existing kind of a calculation algorithm, and I'll show you the new one right away. So we look at the same calculator again. I'll start by looking at the publishing of the event. So we're going to create a mop, and we're going to put this mop in a round requested event. So what's our event? We have requested the rounds. And when we look at the event, and that's actually a very important part, I think, it doesn't contain a lot, but it extends this event. So in this event, we will see that we have an immutable object, and we put the information that we're interested in this mop called data. So we're not putting any POJOs or any entities in there. It is a mop, and the mop only contains the information that we want. It can be about one specific entity, it can be about 25 entities, or it can contain just a couple of fields. Defining the content that goes into the event is probably one of the most difficult parts of doing event-driven architecture. So we really need to focus on what are we going to put in the event, and maybe iterate over multiple cases that might be interested in that published data. An advantage of doing this is that we can use the same event and put more data in it. Of course, not in the event that's already been published, because they need to be immutable. What you could do is store your entity also in your event class for debugging purposes. That's something that, for example, Kenny Bastiani from Spring is advocating to put that in there as well. But when you, for example, serialize it to somewhere, all that information will also be in the representation, and it might not be ideal. Now this event, in our case, is going to be serialized using Avro. Very simple, so you write this specification, and then you can use a Maven plugin to generate an Avro event for you. I'll show you what it looks like. So it's just a generated event that contains a lot of representation of what we have written here. Ideally, when you're creating an actual application, you should use like the schema registry from Avro, where you can store your different schemas or your different versions of these schemas, and then other applications can use it as well. I didn't do this for the demo. I'll show you in a bit what it looks like. But very briefly, when we look at actually producing the message, we see that we have the message from Spring that is of type Avro event, and then we can build this message. What's really cool about using a generic message approach is that this publishing of code is not directly linked to the event, so it can be fairly generic. I created small tests. Maybe I'll change this to weekly, for example. Then you see that I'm not cheating. So we're going to do weekly events, just publish this. My small laptop is being slow today. So what we are doing, we have started with our legacy application. We did a small bit of refactoring. We introduced all the event logic, and we're just going to publish the event that contains all the data that others might be interested in. So that's been done. And when we look at the newer application, so the older application, I forgot to mention that, is running Spring 1.5, so it's very, very old. It's using Java 8, so it should be legacy. And the new application is going to use Java 10 and Spring Boot 2.0 something. So 2.0.2 release, and it's running on Java 10. It should be mentioned here, you can see that. So we have sent this message to the RabbitMQ, and this subscriber has received the event, and then it can actually start doing the calculation. The observing application is maybe even simpler. All it needs is a consumer that knows about the Avro message that's going to end up in it. So we have the same Avro event in here as well. So this is why you probably want to have some kind of repository where you can store these events, because right now you need to make sure that everybody is talking about the same thing. To publish the Avro events, you need to define a message converter. It's very simple. See, it's just using the var keyword, so it's Java 10. Yay. Now, the stream message converter is actually very important because we are putting a serialized event on this queue. When we're using new technology, we need to make sure that when you publish something, that others can read it as well. So it's about backwards compatibility being between Java 8 and Java 10, or Spring 1.5 and Spring 2. Why am I specifically mentioning this? The first time I did this demo, the Spring Boot 2 application was not working because it could not understand the message that was being published. They have changed the stream message converters in Spring Cloud Stream. They have some documentation on how to fix it, but it was not the best out there. It was not very clear for me. So it's the same issue we used to have in the past with Java serialization. If you don't define the serialization ID on your class that's being serialized, and another class from maybe using a different Java version needs to deserialize it, then we will run into backwards compatibility issues there as well. So that concludes the short demo. If I can find my slides again. There we go. So, if we look back at the quote I started the talk with, the problem we are trying to solve is calculating optimal rounds for mail delivery. So we have extracted a new bounded context from the existing application, and we can introduce new tools that really fit the problem that we're trying to solve. And we only need to focus on actually the business, and the business is calculation of rounds. This also works perfectly as long as the messages that are being published are readable by others. Now, when you're moving functionality from a monolithic application to multiple microservices, you're going to introduce communication between these different applications. So these are the Avro events I showed earlier. And I think it's very important that you establish some API guidelines for this communication, because you will end up with distributed spaghetti code, and nobody will understand the events that you're published. Now, that doesn't mean that you need to create these guidelines all by yourself. There's a ton of useful information out there that have very nice guidelines. I've quite a lot of good experience with those from Zalando as a starting point, so I would recommend looking at those very soon, and then maybe you can iterate on them and tailoring them to your specific needs. Now, this talk is not about API design, but there's one quote that I really want to share. It's about postals law. It was written by John Postal when he was writing an early version of the TCP specification, so it's not something new. And it's about being conservative in what you do and be liberal in what you accept from others. So when you are reading something from an API, if it contains more information than what you need, just ignore it. Because if you make assumptions about what's being sent to you, you also need to deal with having those backwards compatible issues as well. It's also known as the tolerant reader pattern. Guidelines alone are not enough, because if you have guidelines but you don't document them, then people will stop adhering to the guidelines probably from the get-go. So you need documented APIs. And this is valid for the events as well. So again, have some kind of contract repository, maybe do consumer-driven contracts where both your publisher and your subscriber know what they can expect. And then look at patterns like tolerant reader, make sure your APIs are extensible. Think long and hard about versioning. Versioning APIs is not easy. A lot of things can go wrong there. I know that from personal experience. So for asynchronous, I kind of like doing it with Avro. It all fits nicely if you have Kafka, but it works with others as well. For synchronous calls, you can typically use Swagger or Hull, and a lot of options available. Now, I started about, this talk is actually called Without Asking Permission, and you might ask yourself, is that actually possible? So in order to innovate without asking permission, what you try to do is establish a culture of continuous experimentation. This is something that a lot of very large companies do as well. They start with something, they see if it works. If it works, they can continue building on that, and if it doesn't work, just throw it away. And try something else. These microservices, they will be small, they will be loosely coupled, they will really enable experimentation and innovation. And that in itself brings up new opportunities, and it's the opportunity of data science. So if you use feature toggles or traffic routing, you can use API gateways or load balancers or service meshes, whatever you like. You can learn more about the behavior of your users. So for example, when we look back at the calculation algorithm, maybe you will want to serve the new endpoints to a certain group of users and the old endpoints to other users, and monitor how the users are coping with those new APIs. Maybe they prefer the older way, or maybe they're very happy about the new way of doing things. So this gives you the opportunity to have a data-driven decision-making, have these metrics in place. I think I told this story last year as well, but at Amazon, they once added an image on their website, and the image did absolutely nothing but record using user behavior. And they changed it, so they put it very large on the left-hand side, then they changed the color and put it on the right-hand side, and they was just looking at, okay, what does this button do? And it didn't do anything. It was just an image, but they learned about the user behavior. They learned where the user was looking and where they needed to put advertisements or recommended products. So in this data-driven approach, you can evaluate the experiments that you're doing. Distributed systems are hard. There's also something that Sander talked about earlier today. The more granular your services will be, the more pronounced the benefits, but also the drawbacks. It is really fun if you can choose new technology, but you should use new technology because you want to achieve some kind of business functionality. It should be technology for business sake, not technology for technology's sake, which can also be very interesting to do, but then it's going to be more difficult to establish a culture where you don't need to ask permission for every change that you're doing. The fallacies of distributed computing are fairly known. I also added a link to them about network reliability, etc., etc. And actually, you should see these as an opportunity. If you're creating a distributed system, you will need to look at things like tracing, monitoring, alerting, because there are so many moving parts in your application that it can be really interesting to also invest some time on this. I think that's also the reason why we are seeing conferences strictly organized around monitoring, and so many tools are coming. Like Spring Boot 2 comes with Micrometer. In the past, there was the actuator endpoints. Prometheus is probably one of the hottest trends right now, so there's a lot of things going on in that area as well. And you can set certain expectations with your customer or your product owner as well. If you have a very nice monitoring dashboard, maybe have a television near your working space, and you can say, okay, we're monitoring everything that's going on. In the past, we were running blind. Now we will see what's happening. You will also see what's happening. That's really something that you can help to sell the ID. If you have seen my tweet, I promised Iron Man. There he is. And I dropped this. It's also a kind of word of warning regarding maintenance. In Iron Man 1, Tony Stark was locked up in a cave, and he built one Iron Man suit, and he had one Iron Man suit, and he was perfectly happy. He just needed to maintain that because he gets shot all the time. There's rockets flying at him all the time. If you look at the newest Avengers movie, he has multiple suits. I don't know how many suits he has. He has suits for Spider-Man. It's like Iron Man as a service that's being offered right now. So he will probably need to have some kind of DevOps culture or some maintenance people because he has so many suits. It becomes so complex. It's not enough to know about one technology stack. You need to know about upgrading, about extensions, about bug fixing, etc., etc. So again, when I said you should not choose technology for technology's sake, it also means that you maybe could benefit from having something like a technology selection, a phase in the beginning where you say, okay, we have identified the different bounded contexts together with our stakeholders. We're fairly certain about how these work. if you have that in place, what kind of technology makes sense for the different use cases that we're looking at. That doesn't mean that it cannot change, because you just have established a system where changing technology is possible, but it should just not come for granted. So it's not a free lunch. Dedicate some time for technology selection. That's actually also a really fun part, because you can be in some kind of room and then elaborate it and go totally crazy with ideas that you say, okay, this is never going to fit. It might just as well be a good match. So again, be conscious about this. Take responsibility, take ownership. If you don't take ownership, if you don't are responsible for what you're building, then creating an application in this manner will be short-lived, and you will not be able to convince your customer or your product owner. Now, in worst case, when you are creating a new microservice, and it just doesn't work out, you have the traffic routing and people are not satisfied with the new version. If it's new, if it's small, if it's well contained, maybe throw it away and create a new one, do it better. So again, small experiments, learn from these and make better decisions in the possible. If you, in the future. If you look at a large monolith application, it will be very difficult if you want to do large changes. If you're running on Hibernate 3 and you want to go to Hibernate 5, I think they're right now, everything will probably break. So this will enable this evolution. Unfortunately, there's also the drawback. So technology is not always used in isolation. If you do microservices, maybe you want to put them in Docker containers. That's really useful. Docker it's not a new technology, but it's still a cool technology. But probably you want to have some kind of orchestration platform as well. Maybe you want to have Kubernetes or OpenShift, or all the different cloud vendors are offering a lot right now. Just by having a legacy application and a new microservice, you will have two running JVMs. They need to run somewhere. In the past, we had very large application servers, and we put a var or an ir, and we just put it on the application server, and the application server did everything for us. There was queuing, there was logging, there was resilience, well, sometimes. It was an HTTP server, it was a logging system, monitoring, load balancing, it did everything. When we're building microservices, that's something that we're losing. So we should be conscious when we take these kind of decisions that we have maybe an orchestration platform available for us as well. Now, there are plenty of reasons why you don't want to use enterprise application servers. If you're running on public clouds, or if you have like the credit card for the company that you're working with, and you can choose cloud services, then this will facilitate a lot of the things that you're doing. In my experience, not a lot of customers really like to have all the developers have a credit card. So you can start to convince product owners or management that this brings a lot of value, that there's a lot of cool ways to do new things, and still making sure that you can maintain the existing application to make it better. And then finally, as promised, a bunch of resources that I mentioned. My small demo application is there available as well. And thank you. If you have some questions. Last slide. This one. I'll tweet the slide deck, then you also have all the different links available. Any questions? I will be here this evening and tomorrow as well, so you can always come up to me and ask me some questions, or maybe discuss about it. Thank you.